today we have Luciano with us. Hi, Luciano. How are you?
Hi, Marco. I'm good. How are you? Thank you for having me.
All good. Yeah. It's a pleasure. Yes, we were just discussing with Luciano that he is the first Italian guest that we have. So today we are like two Italians talking. I hope you appreciate. I don't know.
Yeah, we'll make it fun with our accents.
Yeah, we'll do our best. Yeah, hopefully it's not too distractive from the content.
I hope so.
Yeah. So Luciano, you have two ferries. Well, I have just one, which is here. So I'm very jealous. Where did you get those? I know the answer,
Yeah,
but still.
yeah. Ernest, I think, has been a guest of your podcast multiple times. So hopefully he's gonna appreciate that we both have the ferries there. But yeah, this is coming from Rust Nation UK, the conference that Ernest organizes.
Yeah, for me. Oh, sorry, Luciano, I lost you for a second.
I can see you now. I think you're back, or I am back. I don't know.
Yeah, so you were saying, yeah, you got it from Ernest at Destination. Yeah, Ernest was
Exactly.
my guest at the. Also, I miss you, by the way. Yeah. Each other that often, but hopefully we'll see together again at like some Rust conference or who knows. Yes.
Yeah, that would be great.
Yeah. Cool. So if it's okay for you, we can start.
Yes, whenever you're ready.
Great. So let's go. Welcome to RustShip. RustShip is the podcast for developers who ship Rust code. I'm your host, Marco Iani. I'm a Rust developer and I enjoy talking to other people, especially other developers, and especially about Rust. This is RustShip episode number 8. It's not as frequent as it was at the beginning. At the beginning, I think it was like one episode per month. Now it has been some months since the previous episode went out, but I'm doing my best. It's hard to have a full-time job and also maintain open source and also a podcast. But yeah, I'm doing my best. And it's great to have these conversations with other Rust developers from time to time. Yes. Today, episode number 8, we have Luciano Mammino with us. Hi, Luciano.
Hello, Marco. Pleasure to be here. Thank you for having me.
Yeah, great to have you. Yes. So Luciano is a senior architect at Fortier, which is an AWS cloud consulting. He is the author of Node.js Design Patterns book, and he is an international speaker. He delivered more than 130 talks. So great to have you here. And Luciano is writing a book called Crafting Lambda Functions in Rust. So we thought it was interesting to talk about how Rust works in AWS Lambda and in serverless in general. So Luciano, do you mind introducing yourself?
Yes, I think you did a good job introducing me. I can probably add very little to that. Maybe I can explain a little bit what we do at Fortier, just to put things in context. So we are, as you said, a cloud consulting company. We are AWS partners, so most of our work is focused on AWS. And just to give you an example of the kind of things we do for our customers, we help them with cloud architecture, we help them with developing new solutions or modernizations of existing solutions, moving things from on-premise to the cloud. We do training, team augmentation, cost optimization. This is the kind of activity we do. It's actually quite fun for me because every day can be very different because we have different customers and we have different activities with different customers. And maybe another thing I can mention is that at Fortier we also have a podcast about all things AWS, but also a lot of serverless because that's one of our favorite topics. And this podcast is called AWS Bytes, and you can find it at awsbytes.com.
Yeah, I listened to the podcast, so I highly recommend as well. Yes. Yeah, so tell us about the book you're writing, if you don't mind. Yes.
Yeah, so the book, as you said, is called Crafting Lambda Functions in Rust. I am co-authoring that with James Eastham, and you can find it at rust-lambda.com. And the idea of this book is that we want to cover everything that you need to know if you want to write Lambda functions on AWS using Rust as a programming language. And we're probably going to talk more about the why of these two topics during this episode. But the idea is that it is still a very new thing to write Lambda functions in Rust. I think Lambda, even though has been around since 2015, if I remember correctly, is still a relatively new technology. Like there are companies using it for a while, but it's still up and coming. Like I think we will see that development of Lambda still in the next few years. So I think combining Rust and Lambda together is a little bit ambitious at this point, but I think it's a good bet because I see that as a prevalent technology in the future for people that want to build efficient and cost-effective applications in the cloud in the future.
Yeah. Yeah, we will definitely talk about AWS Lambda more later. But first, let's talk about the book. So maybe there are people who are interested in writing their books. So talk us about, like, for example, is it self-published or not? And I think you are publishing it as long as you write it, right? The book is not finished yet. So talk us about all the decisions you took there.
Yes, no, that's a great question. And I have to be honest, this is a bit of an experiment for me because the other book you mentioned, Not Just Design Patterns, is a book with a publisher, while this is self-published. So it's a very different experience. And it's the first time that I'm going through that experience. So the idea is that we want to have total freedom on how we write the book and the kind of content and the scheduling and everything else. And also we want to try to leverage as much as possible feedback from the readers. So what we decided to do is we effectively created a landing page where you can buy the book. And that was our starting point. Like initially was only based on trust, like we will deliver something. And this was a couple of months ago, I think, at this point. So it's still very early in the process. Like this book is still relatively in its infancy. But we do have a plan. Like if you go on the website, you can see all the chapters that we envision to effectively cover all the topics we want to cover. That structure might change a little bit as we go because maybe we realize that certain topics can be introduced at a different point, or maybe we can split the chapters in a different way. But yeah, ideally, that gives you an idea of the kind of content. As of today, if you buy the book today, you can download the current status of the book, which contains all the preface, all the preamble and everything, plus 2 chapters. I think we are very close to release other 2 chapters, probably another couple of weeks, and we'll be able to publish the other 2 chapters. And with the first 4 chapters, you effectively learn all the ins and outs of Lambda, like how it works and why it's convenient, what kind of applications can you build. Also a little bit about Rust and why Rust it's so convenient when you combine it with Lambda. And then we start building an application. And at chapter 4, you will have a fully functional URL shortener built. Now, it's not going to be the most amazing implementation because there are a lot of rough edges that we will improve in the next chapters. But I think as we publish these other 2 chapters, there is already a lot of value because you can see something that you can bring to production. Maybe I wouldn't bring it to production yet, but something that you could run and see that is actually working end to end.
Yeah, it's cool that the book seems like it has an hands-on approach, so it's not like just theory for 22 chapters or how many they are, but like at chapter 4 you start to deploy something, which is great. Yes, I think it can keep you motivated to finish the book if you see some results early on. Yeah, so it seems that if you like buy the book now, like in the near future, because you're about to release chapter 3 and 4, you said you be able to have a hello world of Rust in AWS Lambda. You told me there is a discount if you buy the book now instead of like when it's finished. Is that correct?
Yes, the discount I think should be about 60%. Now we are gonna be like, we are selling the book on Gumroad, and Gumroad gives you like regional discounts. So depending on your country, the final price might be a little bit different. So hard to say if it's really 60% or less, but I think it's fair to say that it's heavily discounted right now. And this is because, of course, you are a little bit putting your trust into us being diligent and keep working on the book and delivering something of value to you. So hopefully that's a good incentive for people to get the book early. But on the other hand, I will say that if you get the book early, you can also contribute to the book itself. Like, you can give us feedback, you can tell us if there is maybe a topic that we are not exploring, and we might try to cover those topics as well.
There's a Discord server where people can ask you questions related to the book and give you feedback, right?
Yes, you basically get that. I can share the link. I think it's not really a private Discord server in a way, but the idea is that when you buy the book, you get an invitation. So it becomes kind of a channel to provide feedback.
Great. Yeah. Okay. So yeah, we talked about the book. Now, since Rust developers come from different backgrounds, there may be embedded developers, there may be game developers. So let's cover the basic. What is AWS Lambda? What are the main use cases?
Yes, so AWS Lambda is an AWS service. So if you ever use AWS or any other cloud provider, you know that it's a combination of many services. So Lambda is one of those in AWS. And it's a service that gives you serverless compute. And I'm going to try to explain what that means. And if you have heard this terminology FAS, function as a service, this is the category where people will generally put Lambda when they describe different cloud services. So function as a service is the idea that you can write a function in a programming language of your choice. In the case of AWS, probably the most used are Node.js and Python. These are the most used runtimes, but there are so many other runtimes supported, like Java, C#, you have even Ruby, Go, Rust, of course. And yeah, there are so many languages that are supported. And you can even create your own custom runtimes. So if a language is not supported, with a little bit of effort, technically, you can even bring your own language into Lambda. It's an event-driven approach. So the idea is that you write the function, and this function has a bit of business logic, so it needs to do something useful. But this function is not always running. It is triggered by an event. So when you write the function, you also need to define the event that will trigger that function. And then it's all on the hands of the cloud platform. So AWS will make sure that when that event happens, your function is triggered, and then your business logic is actually being executed in the cloud. And this is great because you don't really have to worry too much about the underlying infrastructure. Like, once you have defined the function and the event, this is almost everything you need to define. There are a few parameters you can tweak, but in general, you can take it that way, that you focus 99% of your time on writing the business logic and defining the events that will trigger that business logic. So this is amazing, because if you are building a complex application, or maybe you're building something where you want to iterate very quickly, you don't have to think about all the management stuff like that you generally have to do when you have to deal with servers, like what kind of operative system, how do we install the runtime, how do we keep it up to date, how do we deploy, and do we need complex pipelines that do build and blue and green rollouts. That all the kind of stuff is totally abstracted for you. And we might debate that there are pros and cons to that approach. Of course, you have less freedom, but at the same time, you can focus a lot more on the value that your product is bringing, rather than all this million of technology choices that you can make when you're basically building your own servers. And yeah, what can you build with it? All sorts of things, to be honest. I've seen very wild use cases. But you can think that you can build something very, very small. Like with one Lambda, you can build maybe an integration. Maybe, I don't know, you receive a an event from your CRM and you want to register somebody in a newsletter, maybe that's one integration that you can easily build with Lambda. But you can even build entire applications like web applications, REST APIs. You can even do background processing, like you can take jobs from a queue and use Lambda as a way to process those jobs. So maybe you can do things like sending emails in the background, resizing pictures, processing some data, and maybe storing snapshots of processed data. So it can be very flexible on the kind of things you can build. And generally, when you build entire applications, it's not just one Lambda, but it's a complex architecture where you have many different components working together, different events happenings at the same time, and different Lambdas being triggered to fulfill different parts of the application business logic.
So yeah, thank you for the explanation. Tommaso asked the question in the chat. Did you try their JavaScript environment? It promises to be as fast at cold start time. So maybe we can both answer this question and explain what is the cold start.
Oh, sorry, that was a...
So do you want to answer this question from Tommaso?
Yes, so I think Tommaso is referring to LLRT, low latency runtime, which is a relatively new project from AWS. And I think it's still in an experimental phase. It's not really, I guess, it's not really 1.0, if we want to call it that way. And it's a really interesting project. Basically, the idea of that project is that it's a JavaScript runtime, but rather than using Node.js, it uses a bespoke runtime that they built specifically for Lambda. So it's not something you would use outside Lambda. And they use a JavaScript runtime, which now I cannot remember the name, QuickJS, which basically doesn't have a garbage collector. It's built to be very, very fast and to run in environments that are very resource constrained. So you could even run it like on a smartwatch or an embedded device. Like it's built for that kind of use cases. So it has very good performance for the kind of applications that you will build with Lambda, where generally there is an event, you write some code, it's done. Like you run some code, and then it's done. Like you don't have long running process as such. So it doesn't make sense to have like a just-in-time compiler like the one that Node.js has that is doing lots of optimizations, and then it becomes really, really fast. Because most of the time, by the point that you are really, really fast, you are already done and you need to shut down. So that runtime, I think it makes a lot of sense. The challenge that I see with that runtime is that if you are trying to transition from Node.js, there isn't a great support yet for the Node.js standard library. So there is only a partial support. For instance, streams are only partially supported. And because of that, it might not be so easy to bring your own code into that runtime. So if you're writing something from scratch and it's very simple, maybe you can use it and you get amazing performance without having to switch to a compiled language like Rust. But otherwise, you might find the issue that maybe your libraries are not supported or your code is not fully supported.
Yeah. So this runtime makes, as you said, decreases the cold start, which for the listeners is the time that it takes for your function to start, let's say the first time, right? Then maybe if you're on the same virtual machine, then if your code is triggered again, you don't have the cold start, right? So
correct. Yeah.
AWS doesn't need to load your function. In the case of Rust, of course, there is an advantage there because it's not like JavaScript that you have a runtime. So what's the advantage from that point of view in Rust? I believe it has less cold start time.
Yes, that's definitely one of the advantages. So I'm going to quickly rephrase the idea of cold start and the difference with the warm start. And the point is that this is a serverless solution. So the idea is that if you are not doing anything, there shouldn't be anything running. So this is the whole idea of being event-based. So if something happens that requires some code to be executed, then an environment where this code can be executed needs to be created. And this is the process of cold start. So the first time that event happens in a period of time, probably there was no environment before, so AWS needs to create that execution environment. And that's a complex operation. You can imagine that behind the scenes, AWS needs to create a safe execution environment, so there is some kind of virtualization involved. Then AWS needs to pull your code and inject it into this environment. Then, depending on your runtime of choice, that, like, I don't know, if you use Node.js rather than Python, rather than Java, the language itself has its own runtime that needs to be bootstrapped. So that's also added on top of your initialization time. Then eventually, when all of that is done, your function code can be executed, the event is handled, and if there is a user waiting for a response, that response is propagated to the user. And this is called cold start because effectively to do all this initialization, there is an extra delay before you can process the request and send a response to the user. So if you're building, for example, an API and you're using, I don't know, Node.js, Python, or Java, where there might be a delay of seconds, it's not necessarily milliseconds, depending on how you write and optimize your code, the user might actually perceive that delay. So the first time that they make a request, they might see, oh, this is very slow, and then suddenly it gets a little bit faster, because then once the runtime is up and running, there are multiple requests, and it doesn't need to do that cold start again, because of course AWS is smart enough, once has brought up all of this environment, is going to keep it around for a while in case that there are other requests coming in. Then if there are no requests for a while, AWS will eventually destroy all of that environment to reclaim back the resources and use them for other Lambdas. So this is the difference between cold start and warm start, that initially when the environment is created, you can perceive that latency, while if you have multiple requests, you reduce that the occurrence of cold starts, because there is already one or more environment available to handle your particular request. And Rust can be very efficient in this front, because by the virtue that doesn't have a runtime as a language, like it's built, that you can build very efficient binaries that bootstrap very, very quickly. And also the binaries can be very, very small compared at least to interpreted languages. Then you really get extremely fast cold starts. I've seen in the order of 10 or 20 milliseconds. When you compare it with other runtimes that can be in the order of seconds, like there is a significant difference. And if you're building a web API, for example, a user is not going to notice 10, 20 milliseconds, but they're going to notice seconds, right? So that's one advantage. The other advantage is in terms of pricing, because, and it's probably worth explaining a little bit how the pricing model works. And the idea is very simple. Like if you are not executing anything, like if your application is not being used, you should be paying zero. That's kind of the idea of Lambda. So the idea is that you pay per invocation, but how much do you pay? We need to explain a little bit the formula behind it. And one way we can visualize that formula is like a multiplication between memory and time. So let me explain how that works. So on one side you have memory, but memory doesn't really have a value per se, a monetary value. So what AWS does, they basically say, well, you can pick as much memory, I think between 128 megabyte and 10 gigabytes, I believe is the maximum right now. You can pick whichever value you prefer. And depending on that value, you get an incremental price unit that can change a little bit depending on the region and depending if you use the ARM architecture or the x86. But you can check in the documentation what is some reference prices for amounts of memory. So you can imagine at some point you select a specific unit of price depending on the memory, and then you have to multiply that unit of price by the number of milliseconds that your Lambda function is running. So for every event, let's say if your unit of price was like $1, of course it's like a fraction of a dollar. It's like 0.00000 something. But let's assume for simplicity that it was $1 per millisecond. If you are executing a Lambda for like 10 milliseconds, then you are paying $10 for that execution. Again, I want to rephrase that the prices is like way lower, and you can check the simulator to do some simulation. But the idea is that if you can use less memory and be as fast as possible, then you are optimizing the price in both the two dimensions. And I think Rust is an ideal language for both those two dimensions because it doesn't require a lot of memory. It's actually very efficient in allocating memory and using only the memory that you actually need. So you can probably keep the memory as low as possible. A little bit of an asterisk there that we can discuss more later if you're curious. But in general, you can imagine that you can reduce the memory a lot compared to other languages. And then on the other side, because it can execute code very, very fast, especially if your code doesn't wait for external resources to complete, like it's mostly CPU intensive, Rust is a very good language for performance in that sense. You can also parallelize. Rust makes it very easy if your problem is parallelizable. At that point, you are also reducing the time. So you are reducing both the unit of price and the amount of time that you pay that price for.
Yeah, that's amazing. And yeah, Tommaso said in the chat, another reason it is beautiful, of course, but
Yes.
of course, listeners of this podcast don't need to buy that. Yeah, they already love the language. Yeah. Yeah, that's great. So yeah, to summarize, like it has less like fewer cold start, like like they don't seem like cold start. It has a low memory usage. It means that you are paying less per millisecond, and the fact that it finishes early because it's like it uses like it is efficient as a language. It means that you pay less milliseconds. So yeah, that's awesome. Yeah. So I think we covered the main benefits. What are the cons of writing AWS Lambda in Rust? And also I wanted to ask you how to write AWS in Lambda. Like, are you uploading the binary? What do you need to do to do it?
Those are both great questions. So let's start with what are the cons. Of course, it's not perfect. First of all, there are some limitations that are it's probably worth explaining because as much as I love to use Lambda as much as possible, I wouldn't use it for everything. I think there are some use cases where Lambda might not be the most ideal platform to develop on. And the first limit that is probably the most commonly highlighted when people talk about Lambda is that there is a maximum execution time. So a Lambda cannot execute for more than 15 minutes. And I think this is intentional because they want in order to make the whole event-driven on-demand computation efficient, of course, there needs to be a time bound at some point because otherwise your Lambda could be executing forever and that model breaks. So I think 15 minutes is kind of an arbitrary limit. Originally, actually was 5 minutes. And then because everyone was complaining, they extended it to 15 minutes. I don't know if they're going to extend it more, but I think there needs to be a limit for the model to make sense. So that already removes every kind of long-running process that you might want to run, unless you can re-architect that process and split it in a way that you can compute smaller parts of that process in a way that it takes less than 15 minutes. We've actually done that with some of our customers at For Theorem, but again, it's not something you can always do for every type of computation. Like, I don't know, I guess if you're building a game server, probably you wouldn't do it with Lambda. Maybe there are some weird things you could try and maybe it could work, but I guess it's not going to be the ideal or the canonical way of doing it. The other limitation, and this is currently, I have requested that to AWS multiple times, so maybe eventually we'll get that, is that there is no way to have a GPU attached to a Lambda function. So if you need to do anything that requires a GPU, you don't use Lambda because right now it's not supported. And there are other limitations, like if you need, for instance, specific kinds of file systems or specific types of libraries, it might be tricky to, like, if you really need to have control on the execution environment. There is some room there. You can do custom stuff, but of course that the platform is not designed to be super flexible. Actually, it's designed to be constrained and be efficient for what is meant to be used. Yeah, so these are just some of the limitations, and I think those kind of limitations exclude a class of problems where maybe Lambda is not the best platform to use. And other issues that people generally mention is that the development experience, the local development experience especially, is not always great. And this is something you can probably say in general about AWS, because the more you use managed services that are meant to be used and executed in the cloud, the harder it becomes to simulate those services locally. And there are many different ways that you can still do local development, local simulation, local testing. But there is always a little bit of discrepancy between what you do locally and then what you're going to get in the cloud. So, of course, you are always at risk of doing something locally, looks like it works, then you deploy to the cloud, and it might break in subtle ways that are not necessarily obvious. So there are actually right now two camps of people when it comes to AWS development. People that will try everything to have a local environment and develop everything locally before they ship to production, and other people that decided to just embrace cloud development in a way where they try to ship code to the cloud as soon as possible and then do most of the testing in the cloud itself. I am somewhere in between, like I'm not in one of the two extremes, but it is a problem right now that there isn't really a clear solution that makes everyone happy. So hopefully that answers your question.
Yeah, absolutely. For example, Roy was asking why using Lambda over EC2. And yeah, I think we explained a bit, like there are two different products. For example, in EC2, you need to provide the operating system you want to use. It's a long-running virtual machine, and so I would use it for long-running processes. Instead, Lambda is way more ephemeral, and it's probably simpler to deploy than EC2. You also don't need to patch your operating system for vulnerabilities and stuff like that. Yeah. Of course, if you have like a Lambda running for the same time as an EC2, then the Lambda costs, I think, 20 times more or something like that. It costs more.
Yeah, I think that's a tricky one, because the idea is that if you have an EC2 instance, especially if it's one of the expensive ones, because maybe you need lots of CPU, you need lots of RAM, you need maybe a GPU. The problem is that if you're not then utilizing that machine 100% all the time, you are basically wasting money.
Yeah.
So I think EC2 becomes very convenient and cost effective when you can predict exactly what is the compute that you need, and then you have a constant load over time. If you have a very spiky traffic, then Lambda might even be much cheaper. So it's hard to say that it's always more expensive or cheaper. I think if you have 100% utilization all the time and you compare Lambda with EC2, then EC2 is cheaper. But that's rarely the case. I think most of the time people have spiky traffic and if you have very low traffic, maybe you can have spikes at some point. I think in that case, Lambda is much cheaper. So for instance, for startups, Lambda might end up being so much cheaper than EC2.
Yeah, I got this number somewhere. I don't remember, but I think it's nonsense, because as you said, you need to check like how much your Lambda takes to run, like the memory, for example, as we said. So anyway, so we talked about the cons of Lambda versus other services of AWS, but I wanted to ask you, what are the cons of writing Rust for Lambda? So like compared to other programming languages such as, I don't know, Python, or we spoke about JavaScript, for example.
Yeah, honestly, the only one I can think about is that it is still a new thing. And too many examples out there that you can use as a reference. The tooling and that, because it's a new thing, you need to know Rust or learn it and then you have to figure out exactly how do you write the best Rust in the context of Lambda. And that's where I think over time we will get lots more examples, libraries, tutorials, courses, books as well, hopefully. And yeah, and that I think is going to bridge that gap, because today, if you use Python or Node.js, there is an endless amount of examples, repositories, open source project, helper libraries, people writing tutorial. So I think it's just easier to do it with those languages if you're starting from scratch. And then there is the whole argument, if you're new to Rust, you need to learn both Rust and serverless and Lambda together. It might be a bit of an effort.
Yeah. Okay, cool. So let's say that I want to deploy a Rust function in Lambda. How do I do it? Let's say first, like without external tools, so like truly understand what's happening under the hood.
Yeah, so the way that Lambda supports Rust is through custom runtimes. And this is something that I think AWS does deliberately with all the compiled languages, because it's the same even for Go and C++. And funny enough, Go used to have a managed runtime that was using like gRPC, so you could just ship your own little Go function and they would link it through an existing runtime using gRPC. But they have removed that. So that's now deprecated, and now you have to go with a custom runtime. And my guess is that they do that because by doing a custom runtime, then you have one single binary that contains the whole runtime plus your own code, and that's much more efficient. So when you're going for compiled languages, I think you are trying to optimize for efficiency. So it makes sense that AWS just gives you that approach. And you don't have to write your own runtime, and I don't think I'm explaining what a runtime is, so maybe we'll...
Yeah, that was my next question, yes. So do I need to pick the operating system, for example?
No, it's basically the idea of a runtime is that when you start a Lambda, the Lambda doesn't necessarily know what to do. So basically the way it gets work to do is that there is an internal endpoint, imagine like a localhost type of endpoint that exists only in the context of that environment, where the Lambda can poll for new events. And then there is another endpoint where the Lambda needs to send the result of the execution of that event. And in between, you need to execute your custom handler code. So there is a little bit of, I guess, runtime is the correct term, but you can imagine logic around your Lambda function that it's actually doing that glue stuff where it fetches the event, call your Lambda code, your Lambda handler code, gets the response for your Lambda handler, or maybe an error in case that the execution fails, and then it communicates back to AWS what is the result for that particular execution. So all this extra logic outside your Lambda handler is what is called the runtime. And generally, if you use Python or Node.js, you don't even see all of that stuff because it's kind of built in. You just provide your own code and that's it. You know that magic is going to happen to make your code execute, take the result, and communicate it back. But if you have to build your own custom runtime from scratch, you need to understand those APIs and write effectively it's like a loop that polls this endpoint, gets a new event, calls your Lambda handler, gets the result of that, communicates back the result, and then goes back and poll again, which is not super complicated code, but it's probably something you don't want to write because, of course, there are lots of edge cases. What happens, I don't know, if it times out or if you run out of memory or if there is an exception that maybe was not handled inside your handler. So, of course, it can get tricky to do it correctly. So you want to delegate that effort to somebody else and make sure that you have a solution that is production ready. And in fact, AWS, even though they tell you you need to use a custom runtime, they don't let you write the custom runtime. They give you an official custom runtime that, in the case of Rust, is just a crate. So AWS takes care of maintaining that crate. You import that crate in your project. And then later, you just need to initialize the crate and pass your handler into it. And then the crate is going to do all this kind of work around the handler, making sure you get the events, call the handler for you, and send back the response to the AWS environment.
Okay. So how is this crate called? Like, can we consider it as a Rust AWS Lambda SDK in some way?
So there is also an SDK. This is called, I think it's called the Rust runtime. So I guess if you wanted to do everything from scratch, you can write your own runtime, but I would suggest that maybe just as an exercise to understand the API, if you're curious, I wouldn't go in production with your own runtime. So realistically, you just install this crate, and then you need to write a little bit of boilerplate just to. So this crate uses Tokyo, so you also need to install Tokyo. It's an async function, the handler you are writing, and then at that point, you write a little bit of code just to initialize in your main. You delegate this kind of event loop to Paul, call the handler, and then send back the response to this library. So effectively, there are like 3 lines of code that exist to initialize everything and just make sure that every time there is a new event, your handler function is invoked. So then the next problem is like, how do you ship all of this to AWS? And you should compile this as a binary. At the end of the day, it's like an executable binary. But the problem is that you need to cross-compile for the specific target, which is going to be Linux, Amazon Linux, and you can pick the architecture you want, either x86 or ARM. But depending on which one you pick, you need to make sure you compile the correct binary for that specific architecture. And then you just zip it and upload it to AWS as a Lambda function. So that these are all the steps that you should do if you want to do, I would call it the manual way, but there is a more simplified way if you use specific tools.
Okay, so actually there is a target which is called Amazon Linux, or like is the target just Linux for 64-bit ARM, for example?
So I think Amazon Linux is more the operative system.
Okay.
It's I guess it's more if you need to use system level libraries, then you know that Amazon Linux is the one being used, and maybe you can compile, assuming that those libraries are going to be available.
Okay, and I know there is a tool called Cargo Lambda, which I think you also cover in the book. How does this crate play into this scenario?
Yeah, actually, Cargo Lambda is the thing that is amazing and makes all this process so much simpler. It's effectively an extension of Cargo. People might be familiar with the fact that you can install additional Cargo commands by installing extensions. And Cargo Lambda effectively will make it possible to say Cargo space Lambda space commands that make sense in the context of Lambda. And it offers a bunch of very useful commands. For instance, if you want to start a new project, you can say Cargo Lambda init or Cargo Lambda new, and it will guide you through a series of steps where it's going to ask you, do you want to do, I don't know, an HTTP API, or maybe you want to do something that processes jobs from a queue. And then based on the answers you give, it's going to provide a very nice boilerplate for you. It's going to automatically create the Cargo toml with all the libraries you need, with all the feature flags you need. And it's going to even provide a little bit of code that you can easily use and start working on it. So that's already an amazing first step, because you're not starting from scratch. You don't need to figure out, okay, where do I find the right example? You just run the tool, and the tool is going to probably give you something that is good enough for you as a starting point. Then the next step is you want to test it locally, probably. You want to figure out, how do I execute my code locally once I have something that I want to run? And Cargo Lambda also has a local simulation environment, so it can easily compile your Lambda code in watch mode. So as you do changes, you can keep sending event to your Lambda, and it doesn't really need to, like, you don't need to stop, recompile, send another event. It will automatically watch and recompile for you. So that's another amazing thing. And then when you're ready to deploy, you can do Cargo Lambda build, and either you specify your target architecture, and it's going to cross-compile for that architecture. I think it uses behind the scenes Zig to do the cross-compilation, which is interesting that a Rust tool uses Zig. And then when you're ready, you can even say Cargo Lambda deploy, and it's going to deploy that artifact to AWS. Even though I wouldn't recommend that last step, because I prefer to use tools that can do infrastructure as code, so where you can define all your resources. And Cargo Lambda actually integrates really well with both CDK and SAM, which are probably the most used tools in AWS when it comes to doing infrastructure as code. So CDK and some will build using Cargo Lambda, but then they will deploy using your infrastructure as code tool. So if you need to create, for instance, other resources like an S3 bucket, a DynamoDB table, wire things together, basically you get the best of both worlds. You don't have to worry about how do I build and deploy my Lambda, because Cargo Lambda behind the scenes is doing all of that. And you can still deploy everything else in your architecture with the tool that you generally use to do AWS projects.
Cool. And yeah, one last question regarding this. Is there a way to write end-to-end tests so that invoke your Lambda function? Yeah, not just HTTP. Like, of course, I rephrase my question. Is there a way from your end-to-end test written in Rust to call your function, to trigger your function?
You can do it. There are tools that can help to do that. It probably depends on the kind of function you write and what do you mean by end-to-end, because probably depending on the problem and the type of application, end-to-end might be slightly different. But probably the
integration tests, sorry. Yeah, like tests under the tests directory in the project.
Yeah, you can. I will do that on AWS, but you could probably do it also locally if you set up maybe a simulation environment using, I don't know. I guess the problem there is the more you use managed services like Dynamo, SQS, and so on, the harder it is to run those services locally. So it's probably easier to do it on a real AWS environment. So there are tools where, especially if you use infrastructure as code, it is very easy to create a new stack that is totally independent from your existing application in production. You just spin it up to do testing. Then you probably have some kind of way to generate the events that you want to test. Maybe, I don't know, if it's an HTTP API, you can probably just use an HTTP client and do a request. Or maybe you need to put something in a queue. You can easily use the AWS SDK to put something in a queue to start the flow that you want to test. At the end of the day, you need to have some kind of assertions somewhere to check that the system is performing as expected. And then when you finish, you can just destroy that entire stack. So that's generally the way that people will do integration or end-to-end tests in AWS, just because if you do everything in infrastructure as code, it's very easy to bring up all the infrastructure you need, do all the testing, and then destroy everything. So you don't need to have a testing environment that is running 24/7.
Yeah. Okay. So if my Lambda doesn't have external dependencies such as SQS or DynamoDB, I can invoke it from. Did you get the question?
Sorry, I lost you there for a second. Can you repeat the question?
Doesn't have external dependencies such as a database or SQS, you can trigger it from the integration tests directory, so from your integration tests.
Yes, or you can just do Cargo Lambda invoke and just that will do like a local invocation for you.
Cool. Now we have two questions from Tommaso in the chat. First one is, okay, let's create a Zig environment. Sounds like a fun project. Say, did you try Zig in Lambda?
Not yet. I was actually chatting with Roberto, who is the other person we do the live streams on Twitch about Rust and sometimes about Lambda as well. And we use Zig in the context of some of the streams, like very experimental, just trying to do simple stuff. And we were wondering, like, how easy can it be to do runtime in Zig for Lambda? I'm quite sure that if we search online, somebody has done that, because I don't think it's a very complex effort. But yeah, it could be interesting to try it and use it. But I think it's going to be, in terms of ecosystem, it's going to be even more challenging than Rust, just because I don't know anyone that is shipping Zig in Lambda in production today. I know a few people that are doing that with Rust. Yeah,
certainly Zig is like a can I say, less mature than Rust. Like it's less used in production than Rust. Yes, for sure. So next question from Tommaso is, looks like it's a problem that you saw at work. I don't know. Like it's a very complex problem, I think. Can I create a custom environment that fetches 2 events at a time instead of just only one? I'm curious if I can create polling to fetch events even if the previous one has not yet ended.
This is actually something I wanted to try. I haven't tried it yet, but yeah, I've been wondering the same. I have a suspicion that if you have an event in progress and you keep polling from the endpoint, AWS doesn't give you back anything, but I haven't tested that assumption. So you might be surprised that maybe in Rust you could parallelize multiple Lambda events, and that could give you like a little bit more efficiency, especially because you're using async Rust. If your Lambda is spending a lot of time waiting for resources, maybe doing HTTP requests or getting data from databases, that kind of stuff. Technically, it would be more efficient if you could handle multiple events in the same Lambda environment concurrently. But I don't know if this it's definitely not built, as far as I know, in the current runtime. Is it possible? Maybe, but yeah, it would be something interesting to test.
And maybe it comes from a curiosity about runtimes, not a problem at work. Yeah. Yeah, cool. So next questions I wanted to ask. Let's say that listeners are familiar with Rust, but not with AWS. First of all, is a basic knowledge of AWS required to read the book?
Yeah, that's a good question. So we are trying. I think it's difficult to have a 100% clear idea of what is going to be the persona reading the book, especially because we are taking this iterative approach. But our current position is that we want this book to be for people that have some minimal Rust experience. So maybe they read the Rust book and did some kind of Hello World tutorial. They can read a little bit of the syntax and not feel lost in what the specific things of the syntax mean. Even though I think we are going to make an effort to try to explain some of the less common or a little bit more advanced things that we might use in Rust. But when it comes to AWS, we are trying to be, I guess, as entry level as possible. So, for instance, we in the URL shortener application that I mentioned at the beginning, you need to store the URL somewhere, and we are going to be using DynamoDB just because it's almost like a standard when you use Lambda as a database, and it's so simple to spin up a table and then start to put data and query it. But DynamoDB is not necessarily something that people are going to have to be familiar with. So we have an entire section where we explain what DynamoDB is, provide some examples of how you can use DynamoDB, then explain with the SDK how do you interact with DynamoDB. So how do you read records, how do you write records, and just provide some examples that are totally decoupled from the application we are building. And then when the reader has all the necessary knowledge, then we go back to the application and we explain, okay, now that you understand Dynamo and the SDK, let's use it in the context of our application. So hopefully, if we do a good job, the book is going to be for somebody who doesn't have to be an expert in Rust, but maybe needs to be familiar with the syntax and doesn't have to be familiar at all with AWS. Of course, they need to have an AWS account, so that they need to have done that. They need to have the CLI installed, but then everything else they can probably learn from the book.
Yeah, it's great that you don't give AWS knowledge as granted, because this might also be a way to learn AWS from somebody that only knows Rust, for example, and to put something in, some knowledge into practice. Yes. And yeah, let's say that people in the audience are not familiar with AWS. How do you recommend to get started, apart from listening to the AWS Bytes podcast, of course?
Yeah, AWS is massive. There are so many services. And I think that the first thing that people need to realize is that you don't need to know all of them. Even though I've been using AWS for, I don't know, almost 10 years now, I definitely don't know all the services. I think I still know a very small subset of all the services available. There are like, I don't know, almost 200 probably, if not more. So I think it's important to understand which ones are the services that you need to know. And that can be very dependent on the type of role that you have in your company or the company you want to go to, or in general, in which area you want to specialize. So in the context of the book, we are going to be focusing on everything that is related to building serverless applications. So probably the things that could be more important are things like DynamoDB, SQS, S3, Lambda, of course. And then there are some services that are kind of a baseline that if you use AWS, you need to understand. For instance, IAM for permissions, access control, policies. It's something that you need to know because it kind of comes up everywhere when you use AWS. So that's probably one of the things that you should try to learn, at least the basics at the beginning, because otherwise it's going to feel kind of disappointing that everything you do, there is that piece of knowledge that you don't understand and you have to copy paste and it might not work. It's probably just easier to bite the bullet and learn it straight away. And then when you start to use all the other services, that's something that you know, you understand, and you can use pretty much everywhere. And in terms of resources, the AWS documentation, there is a lot of material there. It's not necessarily the most easy to consume or the friendliest, but they started recently to do lots of initiative. For instance, there is a workshop website where they have lots of interactive workshops. It's all free. You can just build stuff and you can pick your team. Like, I don't know, I want to build a serverless application. I want to build a data processing pipeline. And it's a much more guided experience. So that could be one way to learn about AWS. Or there are other websites like Serverless Land where they provide like lots of patterns and lots of examples. So maybe that's another way to learn if you really want practical ways to learn. Otherwise, maybe just try to do a certification, but that's much more theoretical than practical. I think, yeah, you still need to do a little bit of practice, but you could pass the certification without touching AWS. So it's probably on you to decide how much theory and how much practice you want to have and find what's the right path for you.
Yeah, certifications, I find that they give you a goal. So like you're you're more motivated to study, I feel like. And like maybe, I don't know, there is the discussion, are they needed or not? Probably if you're in a AWS consultancy company, they are valued, yes. Okay, I feel a bit guilty, I'll be honest, because it feels like life is too good with Rust and AWS Lambda. So if you had like, is there anything that you think, like you said, for example, that one con is that there are less examples, less documentation, and like your book is a great fit here. But like, I have the question: if you had a magic wand, is there something that you would improve, maybe in the tooling or I don't know, in the local testing experience? Of course, related to Rust and Lambda, not just to Lambda.
Yeah, that's a good question. I think I'm very happy with the tooling that exists, and I wish that even Node.js or Python had a similar tool like Cargo Lambda, because you can do the same things that you can do with Cargo Lambda with a combination of other commands. It's just not as simple to understand. I don't know, how do I bootstrap a new project? You have to find the example. So I wish that there was something like Cargo Lambda for every runtime, but this is more a critic on the other runtimes, not on Rust. So I also feel guilty in that sense right now. Yeah, I don't know. I think it's just a matter of having more examples. The other thing that is a little bit annoying, but this is a common theme in Rust, is that compilation times can be a little bit slow sometimes. And because you are building, I guess it's not too bad because you're generally building smaller units. Like a Lambda generally doesn't have to have like hundreds of dependencies. So the compilation times are still in the order of a couple of minutes, so it's still manageable anyway. But I wish that was not the case, because in general, when you develop in Node.js or Python, you literally just need to do a zip file and upload it. So it feels faster to do a build and deployment of Node.js or Python or something else than it is with Rust. So maybe that's a little bit of a negative negative thing to mention about Rust with Lambda, but probably about Rust in general.
Yeah, exactly. Feels like the cons we discussed are mainly about like the cons about Lambda and the cons about Rust that we all know. But it feels like developing Rust on Lambda, it's great. There is great tooling, and now I feel like we said it's even better than other languages. So we made the situation worse. Okay, so Rust is awesome.
Maybe the other thing that we can mention is that if you are not familiar with Rust Async, because it's the whole runtime is built for Rust Async, and you need to use Rust Async even when you instantiate your handler, you have async there everywhere. So it might be a little bit intimidating if you're not familiar with Rust Async. And I think that people that have started with Rust, they're not necessarily familiar with Rust Async. So it feels like it's a concept that comes at some point later in the Rust learning journey. So maybe that's something worth keeping in mind as well.
Yeah, if I'm not mistaken, I think it's not even mentioned in the Rust book. So
that's a good point.
Yeah, so like basically the runtime is forcing you to use async there. So yeah, that's a good point. Okay, I'm glad that we found some cons, so we don't seem too much biased. Okay, so now talking about serverless in general, are there other serverless providers that let you write your functions in Rust, and how do you compare those with AWS Lambda?
Yeah, this is a great question, but I have to be honest that I don't have a huge amount of experience with other runtimes. I've used Lambda a lot. I cannot say I've used Rust that much, because it's something I've been using mostly as almost like a side learning quest for the last 4 years. A little bit in production, but still not as much as I would like in production. So hopefully that will change in the near future. But yeah, I've seen that there are a couple of other FAS type of services that allows you to run WebAssembly. So in those cases, I think Rust is going to be a really good fit. And the two that I know are Cloudflare and Fastly. I honestly haven't used them, so I cannot speak to how good or bad they are. I heard people using them and they're generally pretty happy, so I think they might be quite good platform to use. What I can say at very high level is that the difference with AWS could be that because AWS has so many services and there are so many integrations between these services and Lambda, then maybe when you use other platforms, you have a little bit of a more isolated environment and you need to figure out by yourself how to create all of these integrations. So in that sense, maybe AWS is a little bit easier to focus more on the business logic. You just plug in the different kind of events and you don't need to worry too much about how do I get data into that particular environment. So this is something I expect, but it's not necessarily true, because again, I don't really have a very good experience with the other platform. Maybe they make it just as easy to integrate with anything.
Yeah, I'm familiar with Cloudflare workers, and they are trying to create a similar ecosystem where they give you key value, the database, and so on. Yeah, I think a fundamental difference that you mentioned is that AWS Lambda doesn't run on WebAssembly, while the Cloudflare and Fastly, I think they let you write Rust for you have to compile to WebAssembly. And so you have all the constraints of WebAssembly. So for example, some libraries might not be available in a WebAssembly environment. So I think Lambda is more flexible because your code runs on Linux instead of WebAssembly. So you can do way more things there. Cool. So if there are no other questions from the chat, feel free to tag them now. Otherwise, we're wrapping up. So if you are right here, it means you like the episode. So if you want to see more of this, subscribe to my YouTube channel, Marco Iani, or subscribe to the RustShip podcast on your favorite podcast client. Luciano, anything we didn't cover, or how can people find you?
So people can find me, I guess, on my website that you should see there close to my name. There are links for all the other places where I generally am on X, LinkedIn, YouTube, Twitch, whatever you like. I think I'm pretty much in all of these places. So feel free to reach out. I'm always happy to connect with new people and have conversations, especially if you want to keep talking about these topics. I'd love to hear everyone's opinion on that. Anything worth adding? I don't think so. I think I just want to say thank you for giving me the opportunity to be here. I've been following the podcast and I really enjoy it. So it's a pleasure to be here, and I hope people found what we shared today valuable.
Yeah, no problem. So for the people who listening, the website is called loige.co. So it's like loige.co. There are links to the book, to the AWS Byte podcast, all in the description of the episode. And yes, it was a pleasure to have you here, Luciano, as well. I can end with an anecdote, which is that I think you're really like available for other people, because when we first chatted, when I followed you on Twitter, before when it was called Twitter, and I received an automatic message from you saying like, hey, how can I help you? So we started chatting. I believe you also told me this is like my one of the first experience of Rust in AWS Lambda. So I think it's a nice way to wrap up the episode.
Nice. I didn't remember that, but yeah, nice that you mentioned that.
Yeah, so it's great that you are happy to chat with people and hear everyone. Yeah, and I think also the Discord, like having a Discord server dedicated to this book, speaks for itself. Yes, great. Okay, then thanks everyone for listening and asking questions. If you're live, if you're listening to this async, reminder that this podcast happens first live and then it's published to like Spotify and so on. So feel free to follow me on social media to get notified when a new live is available, or subscribe